today we'll be doing the first part on our session, and it will be over ratios, exponents, linear equations, inequalities, sequences, and series. So if we look at that first question here, it involves ratios. If a car factory produces 230 cars per month, how many days would it take to produce 55 cars? Round to the nearest tenth, and it'll tell you that 1 month is equal to 30 days. So first thing we want to do is we want to set up our initial ratio. We know that if a factory car produces 230 cars per month. So that means in 1 month, the factory produces 230 cars. But the question is saying how many days would it take to produce 55 cars? So because we're talking about days, our unit of time, instead of 1 month, they tell us is equal to 30 days. So instead of writing 1 month here, we want to make it 30 days because that's the unit of time we are working with. Now, it says that question is how many days would it take to produce 55 cars? So the left side of our equal sign are the days and the right side are the cars. So that means that we would have to put 55 cars on the right side of our equal sign. That means that the question is how many days, so an X amount of days. So to set up our ratio, we would have 30 over X equals to 230 over 55. And to solve for X, we have to cross multiply first. So that gives us 230 times X, which is 230X, equals to, so if we do 30 times 55, that gives us 1,650. And to solve for X, we just divide by 230 both sides. So that cancels out on the left. If we divide by 230, we get 7.1739. But the question is telling us to round to the nearest tenth, and our 10th place is right here. And you always look at the number after that place, which in our case is a 7. And because it's a 7, we have to round up because it's greater than 5. So that gives us approximately 7.2 days. So another ratio problem. A model of car that's actually 160 inches is made according to Y. How long is the model? And round to the nearest hundredth. So you see here, we are working with a table, and the table has scale letters from W, X, Y, and Z, and each of them has a ratio. So if you look at W, for instance, our W scale is 1 to 5. So basically, if our model is 1 inch, the actual real size of the car would be 5 inches. That's kind of the scaling we're working with. But for our question, we're working with Y. So the one we're working with is the scaling of Y, which is a ratio of 1 to 15. So 1 inch is equal to 15 inches in real life. So let's set up that ratio first. So we're talking about our model, and in our real life car. So if the model is 1 inch, that means that the real life car would be, equivalence would be 15 inches. Now it says, what if the car was actually 160 inches? So actually means that in real life, it's 160 inches. So you have to put it on this right column here. And it's asking how much would the model would be. So that means that the X inches. So if we set up a ratio, 1 over X is equal to 15 over 160. Now what we do is solve for X, we cross multiply again. So it gives us 15X equals to 160. And then we divide both sides by 15. So for X, so X, it gives us 10.6666. Now, they want you to round to nearest hundredths. Our hundredths place is tenths, hundredths, which is right here. And we look at the number after it. So now after it is a 6, which is bigger than 5, so it rounds up to 10.67 inches. And the answer is B, and you have to be careful because if you look at answer choice C, it's 10.66, which is closer to our answer, but not rounded the correct way. All right, so another ratio scenario is if we're talking about similar triangles. So similar triangles, we have the two triangles are similar. Find the value of x. So when we're talking about similar triangles, we can set up a ratio with those similar triangles. How we do that is we essentially have to have the ratios have to be consistent with each other. That means that you can set up a ratio with this side and this side and this side and this side. So you want to make them consistent. You can't mix and match the two sides when you're doing a ratio. So what we can do is we can call the left side is our first triangle, and this is our second triangle. First, second. So the two sides of our first triangle is 3 and 4. And we're saying it's equal to the other ratio of the other triangle, 9 over x. So to solve it, we cross multiply. 3x is equal to 9 times 4 gets us 36. Divide by 3 both sides, solve for x. X gives us 12. So the answer choice is C, 12. Another triangle problem. Two triangles are similar, find the value of k. Now, the difference between this question and the last one is the orientation of our triangle. So we know the two triangles are similar because they're given to us, but they're not drawn in the same position like the last question. So what we want to do is we want to kind of rotate our triangles so that they align to each other. The reason we do that is just to help us see the similarities or the ratios better. So if we look at our triangles here, they both have a 60-degree angle. So let's try to line up the 60-degree angle so we're in the same orientation. So what if we look at our first triangle here and we rotate it? So if we rotate it to make it look like the second triangle, we know that this would be 60 here, 60 degrees. That means that all the other sides have to line up accordingly. So we would have 8 here. Our long side would be 20, and this would be 12. So now this looks similar to the second triangle. Just like before, we named this the first triangle, second triangle. Now, because we know we are given 3 sides on the first triangle and only 2 sides, we can set up a ratio however we want to, as long as they correspond with each other. And we need to have one ratio where it has the 12 and the k, because that's what we're looking for. So we can pick either 8, 4 or 20 and 10, doesn't matter which one we do. So let's say for our first triangle, we pick the ratio of 12 over 8. So the left leg and the bottom leg. So that means we have to do the same thing on the second triangle. The left leg is k on the second triangle, while the bottom leg is 4. Now, again, we can replace the two bottoms with 20 and 10 if we wanted to, but I'm just picking 8 and 4 for this ratio. Just like I did before, we cross multiply. So 8 times k is 8k, equals to 12 times 4 gives us 48. Divide both sides by 8 to solve for k, because that cancels that. So k gives us just 6. So the answer choice is D, k equals 6. Alright, moving on from ratios, we're now moving into exponents. So use the properties of exponents in this expression. So before we actually solve this expression, we kind of have to know some basic properties of exponents. The most common properties we see are, first thing is when we're talking about exponents, we're talking about powers, anything raised to a power of something. And with those powers or exponents, there are certain properties that go with it. And we're talking about, the most common ones we talk about usually is the product property. Basically is when you have x to the m times x to the n. If their bases are the same, all we're doing is just adding up the powers. Same thing, there's a quotient property. If we have x to the m divided by x to the n, that gives us the x to the m minus n. We're subtracting the powers. And another common one we see is we have x to the m raised to the n power. All we're doing is we're just multiplying them together, the powers together. So let's use these properties to simplify our expression. So our expression is we have 4x to the fourth, all raised to the third, divided by 8x to the sixth, all raised to the second power. So what we want to do first is we want to take the third and second power on top of them and distribute them to everything on the inside respectively. So it would look something like 4 raised to the third times x to the fourth raised to the third. And then we can do the same thing as we do on the bottom. So it'll be 8 to the second times x to the 6 raised to the second. So when we do that, now we actually simplify it. So 4 raised to the third is the same thing as saying 4 times 4 times 4, which gives you 64. And then x to the fourth raised to the third is just like the property I mentioned earlier. When you're raising a power to the power, all you're doing is you're multiplying them. So 4 times 3 is 12. And now we do the same thing on the bottom. 8 to the second is 64. X to the 6 raised to the second is the same thing as saying 6 times 2, which gives us 12 again. Now we see that we can now cancel top and bottom because we have 64 and 64 on top and bottom, and x to the 12 and x to the 12 on top and bottom. But everything doesn't just go away. When you're dividing anything by itself, it's always equal to just 1. So our answer is just 1. So answer is A. All right, another exponent question. Simplify the following expressions. So as a reminder, this one, because we're doing with a quotient, we're doing division, you have to remember x to the m divided by x to the n. That's x to the m minus n. We're subtracting the powers. But in order for us to work with any division or multiplication or raising or anything like that, what we need to do is we have to make sure our bases are the same. So that means that our x's can only divide by x's and y's can be only divided by y's. And you can't mix and match. So you can't do x divided by y. So what we're doing here is we're basically looking at x's separately and the y's separately. So let's write them as two separate quotients and then we'll put them together at the end. So we can write this as x to the 7th over x to the negative 7 times y to the 7th, y over to the 5th. Okay, applying the rule on top right there, what we're doing is this becomes x to the top power, which is 7, minus the bottom power. So even though the bottom has a negative, you still have to put a minus because the quotient rule states it's always a negative right there, no matter what. And for the y's, we times y to the 7th, which is the top power, minus the bottom power, which is 5. So if we simplify, 7 minus minus 7 is the same thing as saying 7 plus 7, which gives you x to the 14th. And then y to the 7 minus 5 gets you just y to the 2nd. So that is the simplified expression, which is answer choice C, x to the 14th, y to the 2nd. Okay, so we've been using rules of exponents but to simplify it. Now what we gotta do is we're solving an equation with exponents. So given the equation, solve for x, 3 to the x minus 2 is equal to 25. So like any equation involving x, what we always want to do is we want to isolate the x, or we want to get x by itself. Now we see that we have a minus 2 on the left side. First thing we want to do is we want to get rid of that negative 2. We get rid of it by doing the opposite of it, which is plus 2. But in math, what you do on one side, you always go to the other. So you got to add 2 on the right side as well, because that keeps it balanced. So that cancels. We're left with 3 to the x equals to 27. Now, this is where we kind of have to do an understanding what this means. We're doing 3 to the power of x is equal to 27. Basically, that means that we have to think about what would x have to be so that when you raise 3 to the power of it, it gets you 27. So the most easiest way to do this would be kind of just thinking about going through x's, right? If x equals to 1, 2, 3, and see what we get. So for instance, if x is equal to 1, that would be 3 to the 1 power, which is only 3. Not there yet. When x is 2, what's that? 3 to the 2nd power. That's like saying 3 times 3, which is 9. Not quite there yet. X is 3, we have 3 to the 3rd power. That's 3 times 3 times 3, which does get you 27, because 3 times 3 is 9, times another 3 is 27. So that tells us that that's the correct combination. So that means that x has to be 3 for the answer to be 27. So later on in college algebra, you'll be learning ways to solve it differently. But as of right now, this would be the most appropriate method. So the answer is C, which is 3. All right, moving on to some linear equations. So we said solve the equation. We have 4x minus 5 plus 7 times x plus 1 equals a 6x plus 7. So the way to solve this would be using something called the order of operations, and that's done through PEMDAS. So this is the order you want to follow when you're solving the equation. So PEMDAS stands for parentheses, exponents, multiply, divide, and subtract. So that's the order you want to go to. So if we look at our equation here, first thing we recognize is P, parentheses. We see a parentheses in the x plus 1 here, right? But we can't really do anything because we can't add a variable to a number. So we can't do anything with that, but we want to look outside the parentheses. We see the outside is a 7. What this says, it's basically 7 times x plus 1. So what we can do is we can distribute that 7 into everything on the inside. And thus that gets rid of our parentheses. So if we rewrite this equation, this becomes 4x minus 5. 7 times x is positive 7x. 7 times 1 is a positive 7. And then the right side is still 6x plus 7. So we've gotten rid of our parentheses. Moved on to exponents. There's no exponents here to work with. Move on to multiply, divide. Still nothing on multiplication, division. Now we look at adding, subtracting. So before we try to bring stuff over to solve for x, we want to see what can we combine, what like terms we combine. So we see that we have a 4x and a 7x. They're both x's, so we can add them together. And we also have a negative 5 and a positive 7. So we also add those together. So let's combine them. 4x plus 7x gets you 11x. And negative 5 plus 7 gets you a positive 2 equals 6x plus 7. Now we see that since we're solving for x, we need to get x by itself. What we see, we have an x on the left with 11x and an x on the right with 6x. Now we want to combine them. We want to consolidate it all to one side. So what we can do is we can bring the 6x over to 11x, bring it over to the left side. The reason we bring it on the left side is because technically the 11 is bigger, so we want to kind of keep it there to keep it positive as much as possible. So we subtract 6x on both sides. What it does is that cancels that right on the right. 11x minus 6x gives us 5x plus 2 equals 7. Now we want to get x by itself, so we want to get rid of this positive 2 by subtracting 2 both sides. Gets rid of that. So 5x is equal to 5. And the last step is just divide by 5 both sides. So it tells us that this cancels. But x is just 1 because 5 divided by 5 is 1. So answer choice is C, 1. Alright, now still in the realm of linear equations, we're talking about the equation of a line now. Write the equation of a line in slope-intercept form with the line passing through negative 1, 4 and m equals 2. Now, to understand this, we have to understand what the slope-intercept form is, right? The slope-intercept form is given by y equals to mx plus b, where m is called your slope and b is called your y-intercept. So what these are is if you, for instance, if you had a graph, and a graph always has an x and a y coordinate, a linear equation, because we're talking about an equation of a line, is just a line that is looks something like this. That's the equation of our line. So the equation of line consists of some things. Now, in our slope-intercept form, we have a slope and an intercept, a y-intercept. So let's identify what those are. The y-intercept is basically the point where the line here, the linear equation, crosses the y-axis. So it's in that green right there. And that's always represented by 0, b. And the b value represents our y-intercept. The slope is basically, for instance, if we had a point here, and a point here. Let's call this A1 and A2. We can figure out the distance, the y and x distance from one point to the other. So basically, if you move up a certain amount and you move x a certain amount, so you move up in the y direction, you move x in the right direction, you will get to the other point. That's basically what the slope is. It's basically the rise over the run. So our slope is the same thing as saying rise over run. Or you can think of it as the change in y over the change in x. So if you look at our question here, what are we given? It says write the equation of the line in slope-intercept form, which we know is going to be mx plus b. And it says the line passes through a point, -1, 4, and m equals to 2. So right away we know what our slope is. We know m is equal to 2. So we can plug it straight in as y equals to 2x plus b. Now we need to solve for b. Now without graphing it, we're not sure what the b would be. But what we can do is, what else were we given? We're given the point, -1, 4. A coordinate point is always represented by an x coordinate and a y coordinate. Because we know the x and y, we can now plug them in to these two values right there. So y is equal to 4. So plug in x equals to -1, y equals to 4. That gives us 4 equals to 2 times -1 plus b. So we now know everything. We can solve for b. So 4 equals to 2 times -1 is -2 plus b. Get b by itself, we add 2 both sides to get rid of it on the right. So it tells us that b is equal to 6. But even though we solve for b, that's not what we're looking for. We're looking for the equation of the line, which is y equals mx plus b. So what we do is we take the 6, we plug it back in here. That tells us that the equation of the line, would be y equals to 2x plus 6. And that is in slope-intercept form. So the answer is D. Okay, now we're doing solve the following system of equations. Now, before we were just dealing with one linear equation. Now we're dealing with two, which makes it a system. So there's different methods to solve this, but depending on how your system is set up. So if we look at our system here, we have y equals to -3x plus 6 and y equals to x plus 2. So you see that both equations are y equals, right? So what we can do actually is, because they're both y equals, we can substitute what they are into each other. So basically, if y is equal to -3x plus 6 and y is equal to x plus 2, we can also say that x plus 2 is equal to -3x plus 6 because they're both equal to y. So now we have an equation we can work with, and let's try to solve for x. So first thing we do is, let's say we bring the -3x, bring it over to the left side. So we add 3x, both sides, that cancels that. 3x plus x is 4x, plus 2 is equal to 6. So to get x by itself, we subtract 2 both sides. So 4x is equal to 4. And then the last thing we do is divide by 4. X equals 1. But when we're solving a system of equations, we want two answers, two types of answers. We want the x coordinate and a y coordinate because we want our point. Our answer is always in the x and y coordinate. So we have our x. To solve for y, all we need to do is take this x equals 1 that we solved for and plug it into either equations. It doesn't matter which one you do, it's going to get you the same result. But to make it easier, let's plug into the second one, y equals to x plus 2, because that's more simpler to do, because that'll just be y equals to 1, plus 2, because we just solved for x equals 1, so that tells us y is equal to 3. So our point should be 1, 3. And that's the solution to our system of equations. So the answer is B. So we have another system, but this time it's formatted a little bit differently than before. Before, we both have y equals and y equals on both the equations. Now what we have is 2x minus 3y equals 0, and negative 4x plus 2y equals negative 8. To solve this one, we can do another method, which is called the elimination method. So basically what the elimination method is you want to eliminate or get rid of one of your variables, either x or y, and then solve for the remaining one. And once you solve for that remaining one, you take that value and plug it back in to solve for the other one you just eliminated. So for this one, it all depends on which one you want to get rid of. It's always set up in a way where one variable is easier to get rid of than the other. So if we look at so when we want to eliminate it, what we're basically doing is we're going to add them together to get rid of it. So if we look at our two values of x's, we have 4 and negative 4, 2x and negative 4x, and negative 3y and 2y. We're going to have to add them together to get rid of them. When we're saying we're getting rid of something, when we add them, basically what we're saying is that when we add them together, they need to be 0. So we want to think to ourselves, what can we turn either our x and y's into so that when we add them together, they get you 0. If you look at x right away, 2 and negative 4, there's an easy way we can get rid of the x's. If we were to take the first equation and multiply it by 2, because when we multiply by 2, 2x times 2 gets you 4, and 4x minus 4x gets you 0. That can get rid of it right away. So let's go with that. So when we multiply it, we got to make sure we multiply everything in that first equation by 2. So that gives us 2 times 2x is 4x, 2 times negative 3 is negative 6y, equals 0 because 2 times 4 is 0, and then we rewrite the second equation exactly as it is. Okay, so now that we can get rid of it, we add them together. 4x minus 4x gets you 0. Negative 6y plus 2y gets you a negative 4y. And 0 minus 8 is still negative 8. Sorry about that. So now there's no more x. We just have a negative 4y equals negative 8. So if we solve for y, we divide. So y is equal to positive 2, because that cancels. And negative 8 divided by negative 4 is a positive 2. Now we need to solve for y. Just like the question before, we need to solve for x as well. So we can take this y, and let's say we plug it back into, doesn't matter which one, so let's say to make it easier for ourselves, we plug it into the first one. 2x minus 3y equals 0. So this is now 2x minus 3 times y, which is 2 we just found, equals 0. Simplify, 2x minus 6 equals 0. Get x by itself, add 6 both sides. 2x equals 6. And divide by 2 to get x by itself. So x is just 3. So the solution to the system of equation is going to be a coordinate point 3, 2. Okay. So the answer is A. Now, let's talk about some inequalities here. A cell phone company promotes a program to charge each month a flat rate of $20 plus 6 cents per call. Joe wants to spend no more than $50 for the month he's using the service. What's the least number of calls he will take not to exceed the amount he got? So the first thing we want to do is we want to see what is it we're solving for. We're looking for the number of calls, the least number of calls. So our unknown x variable will be the number of calls. So when we have an x, we need to solve for it somehow. In order to solve for it, we need to set up an equation or some type of inequality in our case. So we look at the first sentence. It says he's charged each month a flat rate of $20. What does that mean? It basically means that no matter what he does with his bill, whether he makes 0 calls or he makes 1,000 calls, he will always be charged $20 regardless. So first off, he's charged $20. Now it says plus an additional 6 cents per call. So plus 6 cents as a decimal is 0.06. 6 cents per call means that for every call, it's costing him 6 cents. So it would be 0.06x, because it'll be 6 cents times the amount of calls, which we don't know what it is. And he doesn't want to spend no more than $50. That means that he doesn't want to exceed his $50 budget for the month. So it has to be less than or equal to $50. That's the amount of money his bill should cost. So we have an inequality now. Let's solve for x. So first thing we do is we want x by itself. So we subtract both sides by 20 to get rid of that on the left. So 0.06 x is now less than or equal to 30. And to get x by itself, we divide by 0.06 both sides. So x should be less than or equal to 500. So he doesn't want to make more than 500 calls, because if he does, he would exceed his budget. So he wants to make no more than 500 calls. That means that his least amount of calls has to be 500, because if he makes 501, that goes over his budget. So the answer is 500 calls, which is answer is D. Okay, now we move on to sequences. So the question is saying, what is the nth number in the sequence? So our sequence is 3, 7, 11, 15. So when we're working with sequences, we have to understand what it means, right? So when we're saying 3, 7, 11, 15, that basically tells us that the first number in our sequence, 1 is 3, our second number is 7, our third number is 11, and our fourth number is 15. And dot, 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 it goes on forever with basically what is the nth number. So there is an actual formula to solve for the nth number. So the nth number to solve for that, or it's basically looking at the pattern. Nth number is basically the formula A1 minus D times N minus 1. So we have to understand what these terms mean. A is kind of like A sub n is like your sequence. A1 is the first number in your sequence. So if you look at our first number in our sequence here, that's 3. Now D represents the difference between each sequence. The difference between each number in the sequence. So if we look at the difference between 3 and 7, that's 4. So it's right up here, 3, 7, 11, 15, dot, dot, dot. So the difference between 3 and 7 is 4. 7, 11 is also 4. 11, 15 is also 4, and so on and so forth. So the difference between each number is 4. So our D is 4. So if we take that and we plug it in, N is our nth number. So we plug it in, we would have 3 minus 4 times N minus 1. So if we simplify this, we distribute the 4. Oh, this should be a plus, I'm sorry. Distribute the 4n. We have 3 plus 4n minus 4. We simplify, we would have 4n minus 1. And that would be the nth, quote unquote, nth number in our sequence. And it should work, because if you test it out, let n be 1. That would be 4 times 1 minus 1. That gets you 3, which is our first number in our sequence. N is 2. 4 times 2 minus 1 equals to 8 minus 1 is 7. Second number. N equals 3. 4 times 3 minus 1, which is 12 minus 1, which is 11. And it goes on like that. So the nth number in our sequence should be 4n minus 1. And this would be kind of the formula we use to solve for it. So you just got to remember that formula. Okay, so the answer is D, 4n minus 1.